Thank you. It's good to see so many people here. Yeah, I'm Laszlo. I work at the Qt company in Oslo, Norway, and well, I work with graphics. Well, I do lots of different things, and by graphics I mainly mean the accelerated 3D graphics. So, I've been doing a lot of things around enabling Qt to use OpenGL, Vulkan, D3D, and so on. And I've been doing, well, some work on the rendering engines behind Qt and Qt 3D. So what we are going to look at in this, well, somewhat limited time slot is really some of the issues or problems that came up when, maybe some of you, when you try to migrate your, typically Qt application from Qt 5 to Qt 6. Because, some of you, sometimes find that, some things, when you start, profiling and really comparing things in depth, in detail, not everything looks the same in those results. I'm thinking of, CPU usage, memory usage, GPU usage, and so on and so on. And what we will have here is mainly, real-world cases that came up during the lifetime of the Qt 6 series until now. And of course, most of these have been, corrected, sometimes fully fixed or at least improved in some way. And then at the end, we are going to look into some of the very latest things. So some new things coming in Qt 6.9, which, might benefit some of you, your applications or devices. So, this picture, which is again the usual Qt 5, Qt 6 comparison picture. So when it comes to this, the accelerated graphics architecture, so this might not be new to some of you. So does this look familiar? You could raise your hands if you've seen a picture like this before, because I think we've been talking about this a lot ever since Qt 6.0 came out, like in end of 2020, that that's been one of the big things that, on Qt 5, like OpenGL or OpenGL ES was everywhere. So that's what everything was built on, starting from Qt 5.0, came out in 2012. But that meant, of course, that, Qt Quick, Qt Fix 3D, multimedia, and some other components not shown there, so Qt 3D and others, those just used OpenGL directly. And of course, the GLSL shaders were, also sprinkled everywhere. And the big difference in Qt 6 is the thing that's in the middle. So there's an abstraction layer, which is like, a couple of thousand lines of new code there. So there's this Qt rendering hardware interface, QRHI. So that's an abstraction. So instead of using OpenGL, Vulkan, Metal, or something else directly in the rendering engines behind Qt, Qt Fix 3D, and so on, well, they use our C++ classes, and then there are implementations, backends for OpenGL, Vulkan, D3D11, D3D12, and Metal. So there's like 5 at the moment. And of course, the shader story is, of course, quite interesting on its own, because, of course, we have to now translate shaders. So as you might know, Qt 6 pretty much prefers these Vulkan-style GLSL shaders, and then we rely on some third-party libraries basically to get HLSL, metal shading language, or OpenGL targeted GLSL from that. So the main goal should be obvious. So the main goal here was, of course, to just enable Qt to work on platforms. So think of the Apple platforms, right? Ideally, when I run a Qt Quick application, it should default to using Vulkan, since, well, that's what the platform vendor prefers. OpenGL is deprecated there. Of course, on Windows, we default to D3D. Of course, there you have the option if you wanted to use OpenGL or Vulkan. And there are more and more cases coming up. So not so long ago, I think with Android, they started talking about making Vulkan the primary API, and maybe not even offering through OpenGLES implementations in the future, but it might just go through Angle to translate from GLES to Vulkan, which is fine. But the good thing with Qt 6 is that Qt does not need that, since it can use Vulkan directly. which is good. Of course, another motivation here was really future-proofing things. So when we, do new features, which are not necessarily there in the legacy APIs. So some of you might have been at the XR talk earlier, where, of course, there's just Qt 3D XR, relies on OpenXR, but last year there's been actually plenty of work done on these lower level layers to enable features like multi-view rendering or variable rate shading. And there, of course, we focus on Vulkan D3D12 and Metal, and well, sometimes OpenGL is still a thing through extensions, but that's less and less of a thing. But the common question here, ever since Qt 6.0 came out, was of course the performance that, what can we expect here? And the general answer is nothing, because it's not like running the exact same Qt fixin on Vulkan will, bring magical improvements that now everything is, 10 times faster. There could be benefits, lower driver overhead for draw calls, or we'll see an example where, even with OpenGL, just because Qt 6 implements things internally differently, there can be benefits. But in other cases, like I said, we have, tons of new code, right, that enables that there are abstractions, so things are more complicated. So sometimes there's a cost to that. And so, as I mentioned before, some of you might find that, maybe some things look less efficient. Think of comparing CPU usage, for example, between Qt 5 and Qt 6. So, there are pros and cons to the thing. So let's look at some of these cases. So first, an example, which is of course going to be a bit convoluted example, or a bit special, because of course it's kind of a case where I know that Qt 6 will be much better than Qt 5. So of course I took this good old Qt 5 cinematic experience demo, right, which, some of you might remember, it's been around for a long time. And of course there are forks of this so that it can run both on Qt 5 and Qt 6. So of course running this, on my Windows machine with OpenGL on Qt 5 and just, look at the CPU usage, well, that's the big green bar. Of course with Qt 6, it doesn't matter if I use D3D, OpenGL, Vulkan, it's a lot lower. So it looks like that, well, Qt 6 is 10 times better, which would be, great for marketing and everything. But, of course, like I said, it's a bit of a special case. So here I, of course, know that, I enabled particles, shader effects, like on the screenshot. And, of course, I know that with some OpenGL implementations, the Qt 5 implementation of Qt with particles leads to a, unexpectedly high CPU usage. So that was a thing. I knew about that. Whereas Qt 6, so even with OpenGL, internally, things are implemented a bit differently, like how we handle vertex buffers and stuff. And that, of course, just avoids that. So even with OpenGL, running this same application on Qt 6, well, it just looks so much better. But of course, in reality, this depends heavily on the scene, what it contains, what code passes you hit in Qt. So, of course, there are cases when the opposite is true, that, maybe Qt 6, the CPU usage would be a bit higher. Now, I don't think we need to talk about the very basic, this comparison pitfalls, right? That, you should always compare release builds to release builds, or things like you should think about persistence, so disk-based caches, so which of course also in graphics we employ, like for OpenGL program binaries, or with Vulkan, we might store the pipeline cache on this. And of course then comparing, say, the second or later run of the application with Qt 5 against the first run of the same application with Qt 6, that might of course give quite horrifying results if this is involved. Because again, if it's the first run, then, the Qt 5 run used data that was already available, whereas the Qt 6 things might start compiling shaders from scratch. But there are more interesting ones. So like this one, which I ran into on my own machine simply because I happened to have 125% scale factor on my Windows desktop. And of course, this is a case that Qt 6 sometimes has, features that work much better because they've been improved a lot, like high DPI. So Qt 6 works like any modern rendering engine should, that, if the I think the QML scene in this application requests 720p, Qt6 just renders, 720p times 1.25, so that's 1600 times 900, which is good. But with Qt5, this whole thing, I think there might be things you need to opt in. But even if I do, so now I need to remember to change the Qt5 version to opt in. But even then, the non-integer scale factor has some, unfortunate effects, I think. So like as the render doc capture shows, so in the Qt5 version was actually rendering at 720p, which of course is a unfair comparison. So sometimes I think this is a bit overlooked, that the render target sizes really matter, mainly for GPU usage, of course, because there are more fragments to shade. But of course that could manifest in, that depends on the architecture, but the memory usage is higher and a little bit also the CPU usage might be affected. So things like that matter. Now, one of the important things, though, is specifically when you are only interested in OpenGL, right? So, but still you want to migrate from Qt5 to 6. So there were cases like found also by us and also reported by your customers that, you run certain scenes, Qt6 scenes, typically things with hundreds or thousands of items, moving around. And I think this typically affects cases when, you change also the items, so the geometry changes. So I think the vertex data then changes on every frame. And for example, in this case, it was found that, when we start profiling this for real, like on, Linux using MSAA as the OpenGL implementation, then, we just get a result where Qt6 is always, slightly slower. So the CPU usage is higher compared to Qt5. And yeah, this is very valid feedback and it's a very valid complaint. So this is a case where, all these new abstractions sometimes made things, just more complicated. Of course, the explanation there is a bit oversimplified, so it's not as simple as, Qt5 could just call GL buffer subdata, and Qt6, there were just additional copies. It's a bit more convoluted, but that's the gist of it, right? That due to different levels of abstractions, with Qt6, the data, like the vertex data, had to just travel through multiple levels, and maybe copies had to be made, maybe with memory allocations even. And the good thing here is that last year there's been quite a lot of improvements made here, which is why the recommendation is that just try to use Qt6.8, that's the current LTS, or newer, because I think that has, really a number of improvements, especially when you run Qt applications with OpenGL. Of course, the solutions kind of involve, making this path shorter while still keeping this whole abstractions architecture sane, so that we avoid doing so many copies and stuff. So the behavior becomes a bit closer to what Qt5 could do simply because it was tied to OpenGL so much. So Qt6.8 or newer. When it comes to memory, so first of all, like I said, Qt6 is very different, deep inside when it comes to the graphics, so the rendering engines due to be Qt 3D. So of course, you cannot guarantee that running the same application on Qt6 will allocate the exact same number and size of memory blocks. So of course, that's not really reasonable to expect that. On the other hand, there were cases in the early days, so Qt 6.0, 6.1, maybe the early 6.2 releases, where due to utilizing caches and trying to recycle graphics resources. So say then Qt there's a change in the scene, maybe we have to rebatch things, and maybe now we have some unused vertex buffer. Well, we might want to keep it for later use. So there's a lot more of this in Qt6 compared to Qt5, and well, I guess that's kind of expected for modern engines. But there were patterns there which were, of course, identified to be not entirely ideal, because we had cases like with Qt 3D, for example, that dynamic scenes, which were constantly changing in certain ways, led to these internal data structures growing. Of course, sometimes these are described as memory leaks. I say memory leaks in quotes because there is no memory leak. That's all perfectly referenced, and data sitting somewhere which is freed when you exit. But still, this is not entirely ideal. So this got tuned, and again, well, already in 6.2, 6.5, 6.8. So again, here, the messages, I think, should be that, use the newest version possible, especially when performing these comparisons, benchmarking or comparing CPU and memory usage. Okay, so this is just a, fun, simple thing. But of course, we had cases where the problem was nothing architectural, really. It has nothing to do with, or new graphics abstraction layers. But, sometimes there were bugs introduced in Qt 6. So this is a case where the SingGraph renderer, the batching was kind of broken for non-indexed geometry. Of course, as the render doc capture shows, this affected, well, very few people, because most, Qt items, the standard items, all use indexed row calls, like there are, like in that cinematic experience where everything is indexed, so this wouldn't matter at all. But then, if you did a benchmark where you had a custom quick item, and you work with the SingGraph API, so you had your own SingGraph nodes, instantiated from C++, like USG rectangle node, where some of those do use non-indexed geometry. And then, well, say you had 100 of these, and then Qt 5 issued one row call, because everything could be batched together, like there was a single non-indexed row call, and when running the same application on Qt 6, well, it issued 100, because nothing was batched together, which of course showed up as a big data, and of course the profiler showed that there's so much time spent inside MESA in the draw calls, but this was of course just a temporary bug, right, which got fixed, and now Qt 6 also does one draw call. Now, when comparing things, one potentially confusing case is when the feature is not there at all. So, of course, Qt painted item is an example of this, where, there's an enum called render mode. It can have two values. Of course, in Qt 6, it also can have two values, because the source compatibility is kept, except that one of the values does nothing. So the documentation screenshot at the bottom shows that that's a value that's called frame buffer object is ignored. And of course, it silently behaves as if the value was set to image, like the first one. Maybe it prints a warning, but yeah, on the debug output. But of course, the difference is huge, because I know in Qt 6, well, until recently, you can't really use QPainter with well, you still can't use QPainter. Of course, it has the OpenGL paint engine, but then, Qt painted item didn't have that plumbing. So, of course, that comparison is again comparing apples and oranges, because the performance is different. Of course, the quality was much better suddenly in Qt 6, because it used the raster paint engine drawing into a QImage that goes in, which of course is a lot higher quality, then goes into a texture. But of course, those texture uploads that of course, presented a much higher load overall. So again, that's something to keep in mind. This kind of comparison is a bit hopeless. But since we are talking about, painted item, so there is a work in progress story, though, to figure this out properly. So that how do we do accelerated 2D drawing? So QPainter style drawings, rectangles, circles, and so on, arcs, in a way so that it's based on QRHI. So it works on, doesn't matter if you use OpenGL, Vulkan Metal under the hood. So I'm hoping that there will be some news about this in the near future, but well, currently that's still work in progress. In the meantime, one thing which came up from our users, customers, I think quite a few times during the last few years, that okay, what is the alternative if you absolutely need Qt painted item and you want QPainter to use the GL paint engine because your application or your drawing is such that it has to have that, it benefits from that. So the answer here was that, well, you can still use Qt frame buffer object. I now have a repository on git.qt.io, which is public, which really has an application that shows both. That's just code on the left and right that basically achieves the same. The difference is that the right one works in Qt 6.0 to 6.8. Well, 6.9 will have a new thing. And of course, the catch here is that, the alternative solution is a bit more verbose, because that's a bit more advanced, like Qt frame buffer object. That's meant to integrate your own OpenGL rendering, right? So it goes into a texture. And of course, a bit more verbose because it works nicer with the Qt threading model. So it's separate objects. One belongs to the main thread, the other to the render thread. The renderer object to the separate synchronize and render virtuals. Whereas Qt painted item is a bit simplistic with that convenient paint method that's called on the render thread with the main thread block. So you don't have these, data races and synchronization problems. But the migration is still quite trivial, even though, of course, it's not, it's still a little work. But so better, this is a case of, better late than never. So I think from Qt 6.9, there's a change there that, okay, the Qt 5 approach will work as long as you still force OpenGL, right? So the snippet here on the left will perform identically with Qt 6.8, because now that setting the render target that in to frame buffer object will have an effect simply by re-adding some of the plumbing in Qt 5, even though architecturally that's not entirely perfect. And as the render doc capture shows that, again, that test application, now there are OpenGL draw calls, so even with Qt 6, and I'm still using Qt painted item. So yeah, the Qt 5 behavior is kind of back if you need it. And as I said, the holistic story for this accelerated 2D drawing, that's coming up hopefully soon. Okay, simple things. So when doing basically the port of Qt 3D to Qt 6, this was before even releasing Qt 6. So of course, sometimes we thought that, it's a good thing to use the, modern things in Qt, which sometimes have a drawbacks or, disadvantages. So for example, when in the texture atlasing, so that screenshot there, that's atlas of this cinematic experience demo. So small images in Qt we get basically put into a single texture. And of course, the code that does this in the Qt 6 port, of course, we just said, it's a good idea to use this newer QImage format that got introduced I think back in Qt 5.2, this RGB 8888, because that's byte ordered. And of course, we love that because then you can just create, RGB 8 texture, with OpenGL, Vulkan, and so on. Whereas, of course, ARGB32, that needs a bit of a dance. If the architecture is little endian, then, it's like a BGRA8 texture, and then if we still want to care about GLES2, that's technically optional, so, it gets complicated. The problem is this is now there was a conversion, because the rest of Qt that came from Qt 5, that just uses the other format. Okay, so of course this got solved for now by, simply, switching back, and then, maybe we revisit this later. So that hit will not be there. And then finally, an interesting thing here, say you run a Qt application on an embedded device, and you follow the typical workflow of, maybe SSHing into that device, starting it, and then you just kill it. It's very common, like you just Control-C from the terminal. And then it was found that, Qt 5 is just so much, faster, whereas Qt 6 does shader compilation, whereas Qt 6 doesn't. Oops. So of course the answer here is, yes, stay there. Simply that with Qt 5, so in Qt 5.9 we introduced, we really query program binaries, whereas before that it was kind of black box. It was up to the implementation if it was doing persistent caching or not. And then we just wrote to individual files on the disk, like when first time we encountered the shader in a shader effect, for example. So the problem with this, there's no problem with this. But in Qt 6, our abstractions are modeled after Vulkan 1.0, because that's a lot more strict in this regard. Like if you are familiar with VK pipeline cache, it's like there are two operations, right? To query an opaque blob containing everything, like all these pipelines, which is state and shaders baked together. And of course, you could seed or, feed that in. So of course, with OpenGL, we kind of emulate the same thing. That, we gather program binaries, have a collection, and when someone queries this blob, it's basically the serialized version of that collection. Of course, who queries it? It's Qt, and when should it query it? At the right time, and then it should, of course, write it to a file, and the next run, it should, of course, feed it in. But what is the right time? There is none. So, of course, the logical thing is that do it when the Qt window is cleaning up, so when the window is closed, application exits. But in this case, obviously, the application is always killed. Well, that just never happened. And of course, that kind of threw off the comparison. So once the application got an exit button, so it exited cleanly, then okay, all this cache data got written out. So then suddenly the behavior became a lot more closer to Qt. So yes. Yeah. And finally, just two Qt 6.9 improvements. One of them is interesting if you're on Windows, right? So that behavior, what's shown there, is not great, right? So when you have a quick item like that rectangle and it, just want it to follow the mouse cursor, there's that lag, so that latency is surprisingly high. And on other platforms like the Apple platforms, this whole window update mechanism, of course, already in Qt got handled a bit better since the platform gave us some quite useful, so CV display links, so quite useful tools, so that you get a callback when there's a time to render a new frame. And now in Qt 6.9 on Windows, we do something similar, which is a bit complicated, but well, we're a dedicated thread that just waits for v blank, signals other threads, and combining it with some other D3D things, so we don't want really triple buffering, right? So that's a bit long for a typical UI. We want more like double buffering. So we'll get, how can I move? Oh yeah, this is example code, but I guess that's many of you familiar with this rectangle and the hover handler. So okay, the Qt 6.8 version is probably not very visible, but it's a bit better, because it has some of the simple improvements. And the 6.9 version is more like what I want. So again, I run this same application running on Windows, the default D3D 11 or 12, if I want to. And well, that's much more like what I want to see, and it's closer to what you see on macOS, for example. And finally, the last thing is that, okay, maybe you don't care about Windows, but you are interested in, embedded and mobile devices, so embedded Linux or Android-based mobile devices. So we can still do, quite nice improvement for OpenGL, it turns out, using some extensions. So, now we have an alternative code path when multi-sample rendering into a texture is involved. And so this affects, like you have used Qt 3D, like you have used 3D item that pretty much always goes to a texture, unless you change the settings. But of course in Qt you have a layer that you enable true and set the samples to 4 times MSAA. So, just having this alternative code path using this quite simple OpenGL function, we just give it our final non-multi-sample texture and a sample count, and we don't bother managing the multi-sample render buffer on our own, and we don't explicitly resolve. So resolve, it would be a GL bit frame buffer with OpenGL. Then the nice thing in this is that if the OpenGL implementation is such and the GPU architecture is such that it benefits from this, because now with this API, it's kind of implied that we do not really care about the actual multi-sample data, we only want the final result. So in some cases, there are some pretty nice improvements. So like one test, it was reported that you run a Qt 3D application, of course in full screen, quite high resolution, on an Android tablet. It was, I think, some quite heavy 3D scene. And okay, this alone, you don't need to change anything in the application, but just by hitting, the alternative code path internally, and then the GPU architecture, I think that was a Mali GPU, was such that it benefits from this. Well, it was reported, the frame rate improves this by more than 10 FPS, which is, 14, which is quite impressive. So yeah, that's just some reasons to move on to newer Qt versions. So of course, as said, you should consider using at least Qt 6.8, the current LTS, but there will be, new things, so quite nice improvements even after that, so 6.9 and beyond, I think. Yes, so our time today is quite limited, so I think that's it from me.